In ACI, we do things a little bit differently than we have in the past. We use a policy to define how devices should be able to talk on the network. This policy is called an application network profile. We tried to make this as easy as possible, and what we do is we take all the devices that attach to the network and we put them into groups. And then we say, how should one group be able to talk to another group? And that happens with a contract. With a contract, we control how one group talks to another. So for instance, if I need my web group to talk to my application servers, I would put a contract between them, and I would say that the web servers are allowed to talk to the application servers over these ports. So by default, ACI is actually what we call a whitelist fabric, or a zero trust model, where nothing can talk on the network unless you define a policy to allow that to happen. Now you can certainly turn that off if you want to, but studies have shown you can actually reduce the attack surface of your network by about 80% if you can adopt a whitelist model. Now the other key component about the policy is that in the contracts we can specify which layer 4 through 7 services we can bring into play. So for instance, people from the outside talking my web servers should always go through a firewall. I can check a box in my contract, specify which firewall they should go to, and now all the traffic between my outside users is going to go through the firewall before they talk to my web servers. We call this service chaining. And for years, it's been very complex to be able to get traffic through firewalls into load balancers and things like that. And now it's become much easier with ACI. So everything in ACI is done with a policy, and everything in ACI is divided up into groups. And we control these groups based on the contracts. And these groups can be web, app, and DB, or they could be VLAN 10, VLAN 20, and VLAN 30. But it's also important to know that we can actually control how we deploy our policy in the network. We call this ACI policy resolution. And we can adjust the resolution immediacy, or when the policy is pushed and programmed onto the leaf object model. Now why would you want to do this? For instance, if I have a policy that I'm defining for only a couple of servers, I might not want to push that policy to every leaf in my network. I might want to say, instead of being an immediate push, I might want that to be an on-demand push, where when I see the traffic for the server, it asks for the policy to be applied, versus a pre-provision where I actually push the policy to the leaf before I ask for the policy. So this is a way that we can effectively use our resources in ACI, but at the same time we know once we define the policy for that application, whether it's immediate or on demand, no matter what, when that traffic hits the network, that policy will be applied. And it doesn't matter whether it's a physical device, a hypervisor or virtual networking, whether it's layer 4 through 7 services, storage traffic, compute traffic, the controller will take care of it for you. Please join me for the next lesson, 8.5, Examining North and Southbound REST APIs.